Okay, so before we start class, you might have noticed that now there's a new assignment. It's on the axial skeleton. The appendicular skeleton assignment will be released pretty soon. So what do you notice with the, or let me just walk you through something real quick. So the thing is, I talked with Top Hat, and now they've said they've fixed it on iOS and iPhone and iPad. Because I know those matching questions, for some reason, I mean, they used to work, trust me. Like a year or so ago, they worked perfectly, and then I think something in the code changed, and now they've had to debug everything. So there is a matching question on the latest assignment, but please read this. So this is a debug question. I'm testing it out if it works again. I've set it so that even if it's incorrect, you still get the full credit for it. But again, it's what you see at the bottom when it says correct or incorrect when next to the submit button. That tells you whether it's a correct answer or not. Again, for matching questions, the check marks may be correct or they may not be correct. But if the overall answer says it's incorrect, that means something's wrong. I think in everybody who's sent me, oh, the check marks aren't working, usually their answer was, I think almost every time the answer was incorrect. So again, don't pay attention to the X's or check marks. Pay attention to whether it says incorrect or correct at the very bottom of a question. All right, so then now let's talk about joints. And again, joints are probably the easiest part of the anatomy of the whole semester because why? Very systematic and very logical. So here we have our shoulder joint, right? So again, our scapula and our humerus forming a joint. And the thing is that it's not scapulohumeral, but it's more about the glenoid plus again the glenoid fossa or glenoid cavity, depending on your textbook. Just for this class, no, it's one and the same. So you just mash glenoid and humerus together and you have the glenohumeral joint. How about the sternum and the clavicle? Well, that's the sternoclavicular joint, right? And again, for this, you have your humerus plus your ulna. So what do you have? The humeral ulnar joint. So again, this is why joints are so cool. They're so easy. And again, this is why you need to know your bones and bone markings. If you don't know your bones or bone markings, you're going to have a hard time naming these joints. Or you can memorize them without even knowing the bones, but again, that's more extra work. Build upon your base knowledge. So joint naming, many joints have bones in their names, but like in the case of the glenohumeral joint, what we had is that it's named after a bone marking and a bone. So the thing is that sometimes you have to know these bone markings and features, and that's why I highlighted certain bone markings because they either a lot of things attached to them or they are many other things in the body and anatomy are named after these markings. All right, so let's talk about planes of dynamic motion. So the thing is that you have monaxial, one axis, then you have biaxial, two axes, and triaxial, three axes. So just like when you have a monocle, you only have one lens, right? And the binoculars, you have two lenses. And then you get like in a bicycle, you have two wheels, right? But how about tricycle, three wheels? So you're just counting one, two, and three. And is there a fourth plane? Well, again, we're talking about three-dimensional space. So remember your planes, like your anatomical planes. How many planes were there? There are only three, right? So you have your X, Y, and Z axis, your frontal, coronal, frontal slash coronal, and then your sagittal, and then your transverse, aka the horizontal plane. So you're going to have three dimensions, and that's why you have at most three axes of dynamic motion. So here's monaxial movement. Again, mono meaning one, and that's the humerus and the ulna. And just like, and this is a monorail. So how many rails does a monorail have? Like the one that's taking forever and is over budget. One rail, right? So again, one rail, one monoaxial, so only one axis it rotates in. So things like your elbow joint, it only really rotates in one axis. So you freeze this part right here, you only have it making one angle. You can't really like freeze your upper arm and then twist it all the way this way. It doesn't really work that way. So again, the humerus and ulna, it just goes in one plane. And the femur and tibia, monaxial movement for the most part in general. So I'll get to a little more about that later. So then these are examples of monaxial movement. They only really move parallel to one plane. Whereas biaxial movement, again, bi meaning two. So again, you have a condyloid joint here. And what do you see? Well, it not only moves in one axis, it actually moves in two axes. So it can rotate two different ways. So here's an example of that. So remember, these are they carpals, metacarpals, or phalanges? Well, again, this is your hand, so these are the carpals, and these are your phalanges over here. These are the metacarpals, where the carpals meet the phalanges. So this is metacarpals over here, and then you have your phalanges over here. So the joints between the metacarpals and the phalanges are the metacarpal phalangeal joints. I know, very long word, but again, this is why I love joint naming. It's very systematic. So they are biaxial movement. Like, where do you have your metacarpal phalangeal joint? Right here, right? So again, how can you move your finger? Well, you can move your finger this way, right? So that's one axis, but you can also move your finger this way, right? So that's another axis. So you do have biaxial movement between your metacarpals and your phalanges right here. So this is a classic example of biaxial movement. And again, this is why, especially for exam 2, your hands and your whole body is kind of your own cheat sheet. So you get, if you do weird things like this, like, okay, if you write something, yeah, then I'll definitely like flag that. But I mean, if I see you like feeling your bones or whatnot during the test, that's fine, because again, this is, you have a skeleton inside your own body. That's totally fine to kind of use that point of reference. And then triaxial movement. So again, this at most 3 planes. So these have the most range of movement because they can move in all 3 directions. So like your shoulder joint, you can move it one way, you can move it this way, but you can also rotate it as well. So the thing is that these, what do you notice? They all kind of have a round head into some sort of socket. And these are called ball and socket joints. So things like here, well, we talked about the glenohumeral joint just a few slides ago. But what about this one right here? Well, you have the acetabulum, right? That vinegar cup, that little cup in your hip socket. And then what bone do we have here? We have the femur, and the head of the femur fitting inside the acetabulum. So acetabulum plus femur makes acetabulofemoral. So again, this is why it's like, oh, I wish everything in anatomy was this easy, but I mean, I wish the person who named all the joints named everything else in the body, but again, this is why build on the bones, build on bone, from the bones, make bone markings, and then you can then start naming a lot of these joints just by knowing all of those facts. All right, so these are the types of synovial joints. This is the OpenStax version, and basically it has all the details. So there are generally 6 categories of synovial joints, but one common thing that trips people up is that they think you can only be one type of joint. Thing is that there are many joints that are, when you study these joints, especially more advanced books, or if you look at like journal articles devoted to just one type of joint, they might have a primary type that they're associated with of synovial joint, but often a synovial joint might have slight activity of another joint. So I'll get to an example of that real quick. So we already did cover functional classifications of these synovial joints. So the gliding joints and the hinge, pivot, condylar, ball and socket, and saddle. So we talked about the intercarpal joints. Again, all the carpal bones, they do form joints with each other, and they do move across each other, so they are gliding joints. And then hinge joints, just like your classic elbow joint, the humeral ulnar joint. And then you have the pivot joint. Remember that atlantoaxial, again, your atlas rotating on the axis, that's a pivot joint. And then you have the condylar, that's the one we talked about, our metacarpal phalangeal joint. Ball and socket, your glenohumeral joint, and your acetabulofemoral joint. So again, your shoulder joint and your hip joint. And then saddle joint we didn't get to yet. So there are, the classic saddle joint is what you call the metacarpal trapezial joint. So again, metacarpals, those bones right here you feel in the palm of your hand. So then the saddle joint, so metacarpal and trapezial. What bone sounds like trapezial? Well, there are 2, right? So again, remember how I don't know who decided to make a trapezium and a trapezoid. So which one is it? Well, remember that mnemonic I had? So go be smart, don't be dumb. Your trapezium is on your thumb, right? Trapezium. So metacarpal plus trapezium is metacarpal trapezial. So this is a classic saddle joint. So remember, look at your thumb. You can move it this way, right? But you can also move it this way. So yeah, so metacarpal trapezial. So this is a classic saddle joint. Do you have to know about the other types of joints that have slight saddle-like movement? This is the one I definitely want you to know. This is a like classic saddle joint. Like there's no doubt about it. The metacarpal trapezial joint is a saddle joint. All right, so then there are complex functional classifications. Like even though we have those 6 types, They're not like individual discrete silos where they don't have any overlap. Like a joint is either one of those six and nothing else. So here we have, you might have heard this term, TMJ, right? Temporal mandibular joint. And whoa, where's your temples? Where's your mandible? So this is the joint that kind of forms that hinge of your jaw. So this is your jaw joint. And what do you see here? So the temporal mandibular joint. So the thing is that it's kind of complex. It both works as sort of a condylar and a gliding joint. It's very interesting. Because again, your jaw, you can put, well, when we talk about joint movements, we might have time at the end of this lecture, but we might not. So the thing is that you can protrude your jaw, you can retract your jaw, you can depress your jaw, you can open it, you can use it kind of like a hinge. So it's kind of like a hinge joint, kind of like a gliding joint. So it's not quite, did I say condylar? I take that back. So it's kind of like a cross, it's like hinge with gliding properties. So you can have multiple types of, a joint can have multiple types of movements and functional classifications. So yeah, this TMJ joint. So actually, if you can try to feel it right here, some people, and this is pretty common, they have like you may have heard this term TMJ clicking. When you open your jaw, if you kind of hear a clicking noise, well, what's happening? All these things right here, this is moving around as you open your jaw and swallow or chew or do things like that. So that TMJ joint. But some people get pain when they have that. So again, if that happens, you might want to see a physician about that, especially if it's impacting your daily life. But yeah, the TMJ joint is not quite a hinge joint, not quite a gliding joint. And another complex joint is your knee joint. It's mostly a hinge, but the thing about your knee, it also has some very, very slight rotation. So the thing is that when you lock your knee, when you extend your knee and make it straighten it out, it kind of like rotates slightly and locks in place. And we'll get to that real soon. The thing is that, what's my main point? There are those 6 types of general functional classifications, but sometimes joints fall into multiple of those classifications.